Wear it, pinch it, swing it, catch it, trigger it, punch it, whip it, swish it, squeeze it. Introducing etee, the button-free VR controller. Designed to be put on in 3 seconds, etee allows anyone to dive straight into VR without thinking. Powered by patented TG0 sensor technology, it senses every finger movement, touch, proximity, pressure, and gestures. etee is more intuitive than any other clunky controllers. With gestural shortcuts built in, you will never need to worry about clicking the wrong button again. Start to play, and once you start, you won't be able to stop. etee Steam VR comes with an ultra-lightweight bespoke tracker. You can now play every game on Steam VR. It takes you away from binary button commands and brings you into a new world of gesture, grip, and touch. PC gamer? Not to worry, etee's got you covered. With smart key binding in place, 3 degree of freedom positional sensing and haptic motor embedded, every fight is more realistic, every operation more sensitive, every player more in control. We aim to build up a community of gamers, developers and artists who are passionate about immersion. We are here to help you realising your inventions with etee Dev Kit, which offers the ability to build with C++, Unity, Python and much more to come. Our team has been working tirelessly since 2018. We now need your support and feedback to take to the next step and bring etee into your hands.
Please back etee!
Tangio is looking to replace electronic sensors with their soft, hypersensitive material. The many switches, joysticks, and buttons that enable humans to interact with electronic products all have the same limitation. They are uninspiring and difficult to use. They are also expensive and complicated to make as they require thousands of complex sensors within each one. TGO is a platform technology replacing electronic sensor networks with one flexible conductive material to sense human touch. The resulting material produces 3-dimensional controls that are ergonomic, intuitive, and engaging. No mechanism is needed underneath, and the material is uniformly molded, so no mechanism is housed within the material either. Instead, the electrical signal output is generated through touch, then transmitted to a microprocessor for analysis. Touch location is detected by using a unique 3D surfacing geometry to produce unique signal patterns. These signal patterns are then put through the company's machine learning software loaded on the processor. Because it can be molded out of one continuous material into a 3D shape rather than assembled parts, it is less expensive and simpler to manufacture. We envision powerful applications for this technology in automotive, consumer electronics, and various other markets. This technology truly shows that an aesthetic language can become a useful technology itself.
There's no getting away from it. They are different. The idea that granular levels of force sensing in a squeeze motion can produce unique grades of interaction in software is quite unusual, and to a certain extent that capability has a long way to go until it becomes a function in most software. But what I related to immediately the first time I used etee is that they are different. They offer the potential for much more precise interactions with a wide range of VR objects.
Hi, I'm Shanna, I'm with TG0, and I'm here with Mick here to talk about etee, TG0's full finger sensing controller, and what it can do for you. So Mick, can you tell me a little bit about what etee does and how it works exactly, and what its capabilities are?
Right. So etee is like a full finger sensing technology VR controller. So we can sense our finger just by our technology. So on air and pressure sensing, and also there's a trackpad, and there are a couple of different inputs. So it can sense our different gesture and different input of interaction in the VR. So basically, just bring the physical hand into digitally.
So etee is compatible with Steam VR, correct? Right?
Yes.
Yeah. All Steam VR games right now.
Yeah. So basically, we're using the Steam VR, their binding system. So as long as it's the game published on Steam, we can it can allow us just using the driver and the binding system inside to play all of the game.
And we're developing customized trackers, correct?
Yes.
And what makes these different?
So as you can see here, the tracker here is quite bulky. So that's why we didn't publish this version. We want to do our own tracker, so it can be more accessible and also more lightweight to handle. So here, if we play with this, the weight distribution on the top is too heavy and difficult to operate it. So after the testing, we just we just do more R&D work to make the tracking system on our own.
So outside of Steam VR, what else can you do with etee as it is?
Right.
I've seen some really cool drone controlling, and what besides like drones, like what else could we do with what can we do with etee?
Yes. So we do have a couple of events, like just like beta testing for people. So some people, some developer asking for like develop music control, and they're using Max NSP, so which is a kind of analog input program, and so I think that's quite interesting, just using etee and control the music by like either tune or pitch by fingers, and you can play do, re, mi, fa, sol. I think it's pretty cool. And also, as Shana mentioned, you can using etee to control drone, because on the trackpad we have two inputs. We can have the two input of the how to show. So on the trackpad side, we have these two trackpads. So either we can to control the drone rotation from this way or up and down, and so on. So we can using different gesture to give the drone have different inputs, as well as the robot arm or like other object you can control with. So like a lot of Arduino base of the dev kit I think is compatible.
So can you tell me a little bit more about how we can customize etee for particular needs and projects?
Right. So if there's a special need for the, so we can break down into a couple of different levels. So for example, you can take the etee itself and using exactly same design, but we can change different outlook, like the silicon layer. We can just change it, but we remain of the layout, plastic layout inside. So to save customize cost, or actually we can redesign the sensor bit to fit your requirement. So in this case, we can like either sense more bigger area or sense wide range of other different controlling. So so as long as you can provide us what's your design request, I think we can just like apply same mechanism into your request.
And in terms of hardware and software, those can be fully aligned to be perfectly integratable to increase functions?
Yes, the hardware and software will be the same, but maybe need to small tuning for the sensing range. For example, if we increase range or something, we need to tune our algorithm and the machine learning to fit with the design. But it's all including our service.
That's great. So we know that ET works on its own. We can use ET for various amount of ranges as is,
Yeah.
Including Steam VR, and then also more control other places. And then we can also customize for specific needs and depending on projects and scale and scope.
Yeah.
Awesome. Thank you.
Thank you.
You're just free flowing. It becomes a series of gestures instead of actually focusing all the energy on gripping the controller. You can instead just focus your energy on which fingers you use and how you manipulate the controller and get different feedback from it at the same time. Absolutely fantastic. Would recommend to every VR user.
Okay.
Hi, I'm Shanna, and I'm here with Mick, the creator of ET, TG0's full sensing finger tracking controller. And we're going to talk to you a little bit about the design of ET and why it's so important. So Mick, can you tell me a little bit about the design and how you kind of created just the look, feel, and shape of ET?
Right. So the ET design, at the beginning, because we got this special technology, so we don't want to follow the traditional design, which is the okay, here's the button, so press that. And so because we have the freedom of the 3D design, so this technology we using the sensing material, which is the conducting material. So we can actually make this into different shape as well, and somehow it will increase the sensitivity or the definition of the range of the sensing. So thanks for that, we can do different type of design in terms of industrial design. So as you can see here, this literally is a buttonless controller. And so what I'm trying to play here, we just want to let people intuitively, when we wear on our hand, and people just naturally have a grab. And as your input to other things should be naturally like that. For example, you pick it up stuff, you should be just pick it up, and that's it. So that's why we just design a very simple cylinder shape, and with a very intuitive input. And so kind of naturally you can see my hand, and the sound is naturally maybe this hand is easy to show. So in this way, your sound ankle is a very nice and no stress ankle for your sound. and also easy to do any type of controlling on the trackpad. And other finger is the same, so you just like naturally grab it. And also the LED buttons, well, we design there's a proximity input, and so as a LED, and you can just like press on top, and you can have another input. So why we design an input here, just we want to create more input, and also we want to do some like different proximity interaction, and also in here we won't accident trigger that much, so it can use as a menu or like some different function in the game. Yeah.
So with this design, it makes it really ergonomically comfortable to use over long periods of time, right?
Yes. So for take the example of the other controller on the market in VR, actually there's no secure on your hand. So for ET, you actually just clip on your hand, and you can also like operating or even typing, so during using. And so yeah, basically, and also we have this phone. So this phone is changeable, can tune in with different sizes of hand, and yeah, I think that's it.
So another thing I think is really important about these that I think a lot of people are very aware of right now is the silicone body and how easy it is to clean, and not only that, it's sweat, water, and dust resistant. I think that's really important right now.
So yes, this is quite this is quite crucial. So at the beginning, we're choosing the material. We just like looking around, and we think, yeah, maybe silicone is because good quality of silicone, actually it can stand really long, but not as plastic. It's like somehow sustainable as well. So and also the silicone itself, it is waterproof and also easy to clean. So so for the hygienic side, you can just like spray on top and wipe it, and you can much easier to work with.
Awesome. Well, thank you, Mick, so much. I think it's really important that we're keeping everything clean.
Yeah, no problem.
Around this time.
Yeah.
Thank you so much.
Yeah, thank you.
I love VR. It's good, but imagine. False wall. So when I was contacted by a London startup called TG0 and asked if I'd like to have a play with their new etee finger tracking controllers, I pulled a hand off. Quick! This is going really not very well.
Let's press record and see what magic we're going to make happen.
That's just amazing! Having talked to TG0 about what they're up to, I do get a genuine sense that what really drives them is a desire to bring something new to the market.
Here we're talking about TG0's first full finger sensing controller, and we have creator Mick here to take us through a little bit of the tech breakdown. Mick, tell me a little bit more about ET.
Yeah. Hi, my name is Mick, and so at the beginning of the project, we're trying to think what's the way to bring our physical hand into digitally. So we, as a kick-off brief idea, so we're just thinking, actually we can using our technology to sense our finger movement. So that's the initial point we do.
And can you tell me about this polymer sensing material that we have?
Yeah, sure. So basically, we're using our technology based on the conductive material, and we're just using the capacitance capability to so basically they are capacitance and resistance, and we catch up the signal and using our machine learning technology to analyze the signal. So in that case, we can reach different signal from your finger, like the distance of your finger and also the press sensing as well.
So can you tell me a bit more about the proximity, gesture, and pressure sensing that we can do with the controllers?
Yeah, so thanks for the technology. So we can just using the plastic itself as a sensor. So to sense your like on-air finger movement, and also on the trackpad side, we using the sense signal reading, but with different machine learning methods, and to sense your thumb movement. So in this case, we can assess different type of sensing. It's not only finger movement, but also we can do different input.
So can you tell me about if we need to incorporate other manufacturing to get this sort of sensing, or or do we just use the plastic itself, right?
Yeah, right. Yeah, so basically we don't extra like hardware components. So the plastic, the black part you see, so this part will directly like we have our connect mechanism, so it depends on the usage, but based on this material here, because it's conductive, so we can using the capacitance and resistance through this type of conductive material, and so actually it can work on a lot of different type of conductive material. For example, some ABS and TPU, TPE, and as long as it's the material can be conductive, so like the loaded with either carbon fiber or the carbon black or powder, then we can use it for this kind of technology. Also, soft material like silicon or rubber type is also work. So soft and rigid. We're trying to push this technology into all different fields. Yeah.
And then so with this, we can use our technology to then significantly reduce PCB and wire and flex usage in people's projects, right?
Yeah. Yes. So nowadays, the product design actually, if you want to do this kind of sensing, you have to lay out the flex or like a lot of different components here and there in order to have this type of sensing. But without technology, actually only a PCB and match with this conductive material, and then so the structure, for example, the structure of ET actually just these two pieces, and these two pieces connect, assembling together and fit with the plastic, and an extra piece of the PCB board, then will be, sorry, I do this part. So PCB. Let me grab a PCB.
Okay.
Sorry, can you ask the question again?
So by using this technology, we can significantly reduce our PCB, wire, and flex usage, right, in other people's products?
Oh yeah, yes, exactly. So we can using the plastic itself as a conductive material, and so we on the PCB side we have the connection with the plastic. So in this case, we don't have to lay out too much like either flex or like internal structure. Because so far on the market, if you want to reach this type of sensing, you actually need to lay out a trackpad there, a button, or like a flex PCB all around of the plastic. So it kind of adding a lot of work and assembling process and so on. So increase the price so much. So with our technology, actually, like we can do double injection of the molding. So all of the sensing sensor. So the sensor here is a material. So the material already there. So as long as we just put the PCB in, and then everything will work as a sensor input.
So that means we can reduce the manufacturing costs, and then also it's a little bit more sustainable because we're not using as many parts and pieces, right?
Yes, and also for assembling, we saving time. So for disassemble, for recycling is also easy as well.
Awesome.